If you're a working electrician, a foreman, or a safety manager here in the United States, this one's for you. Seriously, you could use this in your next safety meeting. We are not here to go over the basics. We're here to deconstruct why some of the most experienced people in our trade, master electricians, can sometimes make the most fundamental and tragic mistakes. You know, in the safety world, we talk a lot about the near miss. It's that heart-stopping moment where something could have gone catastrophically wrong, but for whatever reason, it didn't. These aren't just close calls to be brushed off. They're incredibly valuable data points. They are essentially free lessons that show us the cracks in our systems before anyone has to pay the ultimate price.
But this brings up a really tough question, doesn't it? If near misses are where the real learning happens, and experience is supposed to be the best teacher, why do these free lessons sometimes end up costing our most seasoned professionals their lives? Okay, let's really dig into that.
To get to the bottom of it, we're going to follow a pretty clear path. First, we'll look at the psychology of why experts mess up. Then, we'll introduce a really useful model for understanding system failures. After that, we'll look at the 3 ways our brains can fail in the job. And then, we'll apply all of that to 2 tragic, real-world case studies involving master electricians. And finally, we'll talk about what really matters: building better, more forgiving safety systems. So, first things first, we have to fight our own instincts. When something goes wrong, what's the first thing we do? We look for someone to blame. That's called the person approach. And when it's an expert who makes the mistake, it's so easy to just label it as carelessness or, complacency. But the real story is, well, it's a lot more complicated than that.
And here's the most important shift in thinking we have to make. We have to stop treating human error as the cause of an accident. In modern safety science, human error is seen as a symptom of deeper problems in the system. Your expertise doesn't make you immune to mistakes. Actually, it can create its own unique mental shortcuts, biases like assumption and overconfidence that open up a whole new world of risk.
To really understand these deeper problems, we need a visual. And one of the best tools for the job is the Swiss cheese model, which was developed by a psychologist named James Reason.
So imagine your company's safety program is a stack of Swiss cheese slices. Each slice is a different defense. You've got a slice for procedures, one for training, one for supervision, another for your PPE. Now, the holes in each slice, those are the weaknesses. Some are hidden problems, like a poorly written procedure. Others are active failures, like an electrician skipping a step. An accident almost never happens because of one single mistake. It happens when the holes in all those different slices just happen to line up, creating a straight shot from a hazard right to a person.
The Human Factors Analysis and Classification System, or HFCAS for short, gives us actual names for these slices of cheese. It breaks failure down into 4 layers. It all starts at the top, with organizational influences. Think things like budget cuts or a safety culture that's all talk. That trickles down and leads to unsafe supervision, like a foreman rushing a job. That, in turn, creates the preconditions for unsafe acts, things like being tired or working in poor light. And only then, at the very end of this whole chain reaction, do you get to the final layer, the unsafe act itself. Okay, so we've looked at the big system. Now let's zoom all the way in, right into the human brain at the center of it all. As professionals, how do we actually think and make decisions when we're on the tools? Well, NFPA's 70E, in its informative Annex Q, gives us a really fantastic framework for this. It explains that our brains basically operate in 3 different gears or modes. And the key thing is, each mode has its own unique way of failing. If you understand which mode you're in for a certain task, you can actually predict the kind of mistake you're most likely to make.
Okay, this table is where it really gets interesting. First, you've got skill-based mode. That's your brain on autopilot. It's for all the routine stuff we do without even thinking, like stripping a wire. The danger here isn't that you don't know how to do it. It's a simple slip of the hand, or, and this is the big one, a lapse in your memory. Then there's rule-based mode. That's when we use an if this, then that procedure for a familiar problem. The mistake there is just applying the wrong rule. And finally, knowledge-based is for brand new, complex problems where you have to think it through from scratch. The danger there is just getting overloaded. Now, for an expert electrician, most of the day is spent in that automatic, skill-based mode. And that's exactly where the simplest and deadliest mistakes are hiding.
All right, let's make this real. We're going to apply all this theory to a tragic case that was investigated by NIOSH, the National Institute for Occupational Safety and Health.
And let's be crystal clear about who the victim was.
This wasn't a green apprentice. He was a 35-year-old master electrician. He had 12 years in the trade, ran his own business for 5 of them, and was working as a field foreman. By any definition of the word, he was an expert.
So here are the hard facts from the NIOS report. The task itself was totally routine, stripping insulation on a 277-volt lining circuit. Now this is critical. He had turned that same circuit on earlier to test an emergency light for the GC. He was working by himself, a long way from the panel, in what the report calls a poorly illuminated hallway, and he was under a ton of pressure to get the job done for a fire marshal inspection. He was not wearing any PPE. So what went wrong? This wasn't a knowledge problem. He absolutely knew the danger. This was a classic skill-based lapse. He was on autopilot, doing a task he'd probably done 10,000 times. After the interruption of testing that light, his working memory just failed him. He assumed the power was off. He simply forgot he had left the circuit energized. It was a simple, tragic failure to test before you touch. And you can just see the Swiss cheese model in action here. The holes lined up perfectly. You had an organizational failure, that intense time pressure. You had a supervisory failure, letting him work alone on a potentially energized system. You had a precondition, the poor lighting that hid any visual cues. All of this created the perfect storm for that final unsafe act, the memory lapse, to become fatal. Now let's look at a different kind of expert failure. This case also comes from a NIOSH FACE report, but it involves a completely different kind of mental mistake. And again, we're talking about an undisputed expert, a 53-year-old master electrician doing what was described as routine maintenance. But this time, the environment is a whole lot less forgiving, a 2400-volt utility substation. So the job was to service a circuit breaker that had already been taken out of its cabinet. His work did not require him to go inside the cubicle at all, but he made a conscious choice. He manually lifted a red backlight safety barrier, an engineered guard, so he could reach into the energized bus area probably just to do a little housekeeping and dust it off. He believed his skill and his experience meant he could do it without getting hurt. The analysis here is completely different. This wasn't a subconscious slip or a memory lapse. This was a conscious violation, a deliberate decision to bypass a safety control. It is a textbook example of expert bias, the belief that your personal skill allows you to manage a risk that the rules say you shouldn't be taking in the first place. It was a shortcut, and it was driven by overconfidence. As the report itself says, his status as a master electrician did not protect him. So let's run the Swiss cheese model one more time. The investigation found that the utility didn't have a comprehensive, enforced safety program. This led to a supervisory failure where critical life or death decisions were just left up to the individual employee. The precondition then was the victim's own overconfidence and his misperception of the risk. And the final unsafe act was deliberately defeating a physical barrier. The system allowed an expert's single bad judgment call to become the only defense. So, if we accept that even the best, most experienced, most careful people will eventually make slips, lapses, and bad judgments, then what do? Well, we stop trying to create the perfect human, and we start building systems that are resilient to human error. We build systems that are forgiving.
And that brings us right here to the hierarchy of controls. A lot of times we focus on PPE, but I want you to notice it's at the very bottom. It is the least effective control, because it only tries to reduce the injury after every other defense has already failed. More effective are administrative controls, like procedures and training. Even better are engineering controls, like that barrier from our second case. But the most effective control, the only one that truly, completely removes the hazard, is elimination. For us, that means establishing an electrically safe work condition. It means de-energizing, full stop. It's the absolute core of Lockout/Tagout and the foundation of everything we do.
So I'll leave you with this final, critical question to take back to your own job site. We know the human brain is going to make a mistake. It's not a question of if, it's a question of when. So is your safety system, the one you work in every single day, built on the fragile hope that you and your crew will be perfect every single time? Or is it designed with the humility to know that you won't be, and built to protect you when that inevitable mistake finally happens?